Well, let's see how you did on this one. No right angle. First of all, first thing we really should do is check to see if there's a right angle, because that'd make finding the area a whole lot easier. How would we check that? Okay. And how do we know which side to make A, B, and C? Yeah, your longest side would have to be C. The two short sides would have to be the legs if it were a right triangle. So we're going to go ahead and set that up. 13 squared plus 17 squared. Does that equal 18 squared? I'm not going to put an equal sign in there. We're asking a question. 13 squared is 169. 17 squared is 289. 18 squared is 324. And I can tell you right now, nowhere near adding up. This is what? 458. Does not equal. So it's definitely not a right triangle. So then what's our options from there? If it's not a right triangle, how do we do it? Hero's formula. What is the first step in Hero's formula? Perimeter. So 13 inches plus 17 inches plus 18 inches gives us 48 inches. Step 2, to set my perimeter, which is just the perimeter divided by 2. So 48 divided by 2 is 24 inches. And then, okay, so the area is, first of all, it's 24 times 24 minus A, 24 minus 13, times 24 minus B, so 24 minus 17, times 24 minus C, so 24 minus 18. So, it's 24 times 24 minus 13 is 11, times 24 minus 17 is 7, times 24 minus 18 is 6. 24 times 11 times 7 times 6. 11,088. Now I just have to square root that. Now remember, we discussed this yesterday. You can do square root and then do the answer key on your calculator. So it just says take the previous answer. Hit enter 105.299, 105.3 it looks like. What units go on there? Inches squared, because we were dealing with lengths and inches. 105 inches squared. Generally, the problem will either say, or I mean, significant digits could come into play, but in a calculation like that, that's pretty complex to do significant digits because you're adding, you're dividing, and I'm not going to make you do significant digits, don't worry. But generally, 1 or 2 decimal places. I mean, that one was just kind of natural because it was 0.299. I mean, whether you round it off at 1, 2, or 3 decimal places, it's still going to round to 0.3. But there really isn't a rule of thumb that we'll use. Anybody have any questions on using Hero's formula?
So we use that formula because the 458 and equal to 251.
Yep.
That's how I know that one side.
Yep. If these had come out to be equal, then it's a right triangle. Then we would know this was a right angle, but it's not. I'm going to erase that so you don't think that's a right angle anywhere. And then it would have been just, the 2 legs which form the right angle. Remember, for area, you have to have 2 dimensions that are perpendicular. It would have been those 2, multiply them together and divide by 2. Let's do one more example. How many of you got that 105.3? Good deal. Give this one a shot. What do we find when we do this one?
Right triangle.
It's a right triangle. When we go to check this out, 16 squared is 256. 30 squared is 900. 34 squared is 900 or 1156. Those do add up. It's right angle, and where's the right angle at? Between the 16 and the 30. So the area, 16 inches times 30 inches divided by 2. Otherwise known as 240 inches squared. It's a lot easier when they work out that way, isn't it?
Oh yeah.
Yeah. You guys had a homework packet yesterday. Did you guys have any questions off of those that you want me to go over? Yeah. So number 19, this is page 145. Triangular piece of land is bordered by road on one side, stone wall on the second, barbed wire on the third. So 428 feet, 1,000 feet, and 862 feet. What size is the lot in acres? So, I'll tell you right now, it's not a right triangle. I should put the third zero on my 1,000, shouldn't I? It's not a right triangle. It'd be nice if it was, but it's not. So how do we find its area? Add them up. Find the perimeter. Which is what? 2290? So our semi-perimeter is 1145. So our formula for our area, square root of 1145 times, now I'm going to do the 1145 minus the 428 is going to be 717. I'm just shortening it up a little bit. 1145 minus 1,000 is 145. 1145 minus 862 is what? 283? Is that right? Does that look right? Yeah? Good enough. Okay. So now we got to multiply those all out and square root. 1145. Gives me 183,543 square feet. How do we convert square feet into acres? One acre is 43,560 square feet. So this is telling us we're going to divide by 43,560. 4.21 acres. Just so you know, acres are almost always rounded to 2 decimal places. So you guys want me just quickly read through the answers for that since you don't have the back of the book to look at? Start on page 144 there. Number 1. Side C, and let me know if you disagree. I just kind of jotted these in quickly. Side C is 9.23. Perimeter 21.6. 2, side C is 7.19. Perimeter 17.01. 3, side C 7.99. perimeter 18.96. 4, side B is 4, perimeter is 12. 5, side A is 12, perimeter is 30. Any questions on the first 5? Good. 6 through 10. Find the missing side and then the area. Number 6, the side C is 9.2. Area is 17.04. 7, side A is 3. Area is 6. 8, side C is 8.4. Area is 17.11. 9, side C is 7.16. Area is 10.24. And 10, side A is 5. Area is 30. Any questions on those? How many of you have all 10 of them right so far? How many of you want to cry and go home? Anybody have anything you want me to go over, or you know what you're doing, or?
No, I should get what formula goes with it.
Well, the key on 1 through 10, both of them, they tell you it's a right triangle. Okay, when it tells you a right triangle and it says find the missing side, that is always going to be a squared plus b squared equals c squared. Right triangle, the missing side, always. Then, of course, perimeter is just a plus b plus c. Add up the sides. Area, if this is a right triangle again, this is all right triangle. Of course, the perimeter is a plus b plus c no matter whether it's right or not. It doesn't matter if it's a right triangle. But the area, if it's a right triangle, then just a times b over 2. Because a and b would be your two legs. They form the right angle. I don't know if that helps much. The biggest thing is looking.
That's the easy way, basically.
Yeah.
What you're saying.
Well, yeah, the biggest thing is look for those keywords. Right triangle, missing side. Then you know, okay, it's got to be a plus b equals c. Then once you have all 3 sides, then the area and perimeter fall into place. Now, 11 through 15, they tell you that it's an oblique triangle. Any of you ever been called oblique? No?
I've heard people calling other people
Obtuse
obtuse.
is different. Obtuse means you see the big picture, but you don't focus in on the little details. Acute means you see the little details, but you don't see the big picture. Oblique triangle, of course, is a triangle that isn't right. So if you're being called oblique, they're saying you're not right. Hopefully you've never been called oblique. But anyway, oblique triangle means it doesn't have a right angle, which means perimeter is still going to be a plus b plus c. But the area, that's where we got to use Hero's formula. Makes life a lot less easy for us. Notice, by the way, that in an oblique triangle on 11 through 15, they don't have any missing sides because the a squared plus b squared plus c squared doesn't apply. So you wouldn't be able to find a missing side. At least not right now. Next semester, when we do trig, we'll figure out how to find missing sides even of oblique triangles. I'll enjoy it. So anyway, you'll probably be okay with it. It'll happen. Number 11, finding the area is 17.22. 12, the area is 412.7. 13, area is 29.8. 14, the area is 18. And 15, the area is 26.53. Any questions on those? Anybody have all 5 of those right? Anybody have no clue how I got any of those answers? Okay. Now that you have does anybody need me to read the answers again so they can jot them down so they can look at them later?
Yeah.
Do you want them one more time? 11 is 17.22. 12 is 412.7. 13 is 29.8. 14 is 18. And 15 is 26.53. So if you want to try to rework those, and hopefully you understand them a little bit better now. If you want to try to rework those and see if you get those answers, great. If you can't get those, let me know. We'll go over them more later. Okay, 16, find the area. Well, we've got a base and a height, so it's just base times height divided by 2. So 14.96 square inches. 17 is a little bit different the way it's set up. We haven't seen many examples like this. But the 4.5 here is still the base, and even though it's off to the side, the 4.2 is still the height. So it's just going to be 4.5 times 4.2 divided by 2, which is 9.45. 18. The trick with 18 is since these angles are both 45 degrees, this is 8.3, this is also 8.3. So it's just 8.3 times 8.3 divided by 2 is 34.45 square inches. 19 is the one we went over, 4.21 acres. Any questions on those last few?
19 is what?
4.21 acres. Okay, on to number 20 on the next page. Area of the window. When you're given (3 foot 6 inches and 2 foot 9 inches), we can't use those numbers to find areas. We have to convert either all into inches or all into feet. I believe it doesn't say area in square feet, so it'd make more sense to convert them into feet. So 3 foot 6 is 3 6/12, or 3.5 feet. 2 foot 9 is 2 9/12, or 2.75 feet. So you make a right angle so we can multiply them and divide by 2 to give us 4.8125. So 4.81 square feet. (21) is asking you to look back at that same problem and find the amount of trim to go around a window. If you added up the sides, you'd end up with 11 feet. A little less than 11 feet. But it says to add 2 feet for waist. So 13 feet is what you're going to get when you round it to the nearest foot. 22. To the nearest 16th of an inch, how long is the exposed glass? This is a squared plus b squared equals c squared. Then you subtract an inch off of each end because there's a frame around the glass. I get 6 foot 5 3/16. 23, this is going to be Hero's formula because you got triangles. They're equilateral triangles. They're 4 foot on a side. Got a perimeter of 12, semi-perimeter of 6. You get 6.93 square feet. Any questions on those 4 on that page?
Can you repeat 23, please?
23?
3.69 square feet.
Oh, 6.93 for 23?
6.93.
Yep. You look confused.
I'm not, I was just looking at it. He looks that way all the time. Just his look.
Well, it's 4 foot on a side, right?
Yep.
So that means your perimeter is 12 feet. So your semi-perimeter is 6. So your area is 6 times 6 minus 4 is 2. 6 minus 4 is 2. 6 minus 4 is 2. So that means you've got the square root of 48 which is 6.93. Any other questions? On to 24. 24 is 106.167 square feet. Again, you got to change that 8'2" to 8 2/12. So 26 times 8 2/12 divided by 2, 106.167 or 17 square feet. 25, this is a Heroes Formula problem. 17,829 square feet. And finally, 26. To find the end, or to find the square feet of each side of the roof, it looks like, or the end of the building, it looks like 326.7 square feet. 327 would also be acceptable there. Any questions? As I said, those packets are a lot of fun. We're going to have a few of them in our future. So now, just to make sure, I've got a master pack here, but I think I broke yours down. Was that the last page in your packet then?
Yeah.
Okay, good. So now I know exactly where we're at. Okay. So now our next step, moving on from triangles, with what we've learned we can do some stuff. Let's say that's 12 inches, and we're told that this is 5 inches here. Now, just a warning, my drawings are not done to scale by any means. So that's 16 inches. Oh, let's see here. This is going to be 37 inches total across here. First thing I want you to find is the area. Do you remember how to find the area of a trapezoid? Okay, go ahead and find the area that quick. Formula for a trapezoid area, what do? We average the bases. So here the bases are 16 and 37. So 16 plus 37 divided by 2. Then times the height, which is 12. So 16 plus 37 is 53. 53 divided by 2 is 26.5. Times 12. 313. Sound right? 318. Yeah, you're right. 318. And that's square inches. Do the rings in inches. If I were to ask you to find the perimeter, could you do it? Well, I have the top is 16 and the bottom is 37. Do I know these sides? Oops. We can figure this side out easy enough, yep. This is going to be 5 squared plus 12 squared. If I call this C equals C squared, right? 5 squared is 25. 12 squared is 144. That adds up to 169. So now we got to square root it. 13 equals C. So that is 13 inches. Now, somebody asked if it's symmetrical. No, it's not. But if I draw this in here as a right angle, I know that's also 12 inches, right? I know this is how much? What's that? The 12 and the 12?
The 16 and the chunk of the bottom line.
Oh, well, they have to be parallel, otherwise it won't be a trapezoid. Definition of a trapezoid, the bases are parallel. So they got to be parallel. So that's a good assumption. And since these are both right angles, that means the 12 and the 12 have to be parallel. So if the 12 and the 12 are parallel, then we know that this is also 16 inches, because it's a rectangle. So 5 and 16 is 21. This here has to be 16 inches. So that means we can find this one. That's going to be 12 squared plus 16 squared equals, we'll call it x squared. So 144 plus 256 is 400. Square root that is 20. X equals 20. Now you can find the perimeter. 13, 16, 20, and 37. Like 86 inches. What do you think? Are we still better than a sharp stick in the eye? Okay. Well, what's next? It works better for me if I don't try to be so careful and I just draw it quick. Pretend that's a circle. Pretend that's the center of the circle. I warned you guys before, I'm going to be drawing pictures for a while, so you're going to have to do a lot of pretending. Parts of a circle. That is called the radius. That is called a diameter. Anybody know what that's called? It's called a sector. The little pie wedge or pizza slice is a sector. That is called the circumference. That is called an arc. Very good. So we have sectors and arcs. An arc is just a piece of the circumference, and a sector is just a piece of the area. Then we also have something like this. The diameter is actually just a special type of one of these. There you go. It's called a chord. It's a line segment that has its endpoints on the circle. A diameter is nothing more than a chord that contains the center of the circle. So, if I have a circle, with a radius of 4 feet, how do I find the circumference? Pi times diameter. So do pi times 8. Where did the 8 come from? Double the 4. Yep. Radius is 4, diameter is 8. So 25.12 feet. Area would be pi times radius squared. So pi times 4 squared, or about 50.24 square feet. What if I cut a section out of here, a sector that's 60 degrees? Now, we've talked a little bit about half circles. If it's half a circle, you find the this, to find the area, you find the whole area and divide by 2. Or to find the circumference or perimeter, you find the whole circumference and you divide by 2. Quarter circle, find the whole thing, divide by 4. 60 degrees, however,
You would divide the circumference by 360 and multiply by 2.
perfect. The whole circle is 360. So that is 60 3/60ths of the whole circle. So if I want to find the arc length from here to here, it is a fraction of the whole circumference. What fraction? 60 3/60ths. Or 1/6, yes. So that arc length is the circumference, 25.12 times 60 over 360, which is going to give me 4.187 about feet. Look good? What if I want to find, I can't color very well either, just apparently. What if I want to find the area of that sector? There you go. The sector area, by the way, the abbreviation for sector area looks like this. A with a pi wedge next to it. This would be A with a circle with it next to it. That's the area of the whole circle. This is the area of the sector. Is the area of that whole circle 50.24 square feet times the 60 over 360, or times 1/6, which is going to be 8.375 about square feet. What do you think? Am I off? Well, 375, close enough. Good enough. 373, how's that? If I'm within 2,000s calculating in my head, you're going to let it slide.
Remember that when you're grading, huh?
If you're within 3,000ths of a percentage point of an A, I'll give it to you. So we have a circle here with a diameter of 10 inches. That's 40 degrees. Find the arc length and sector area. See what you come up with. Well, we're running a little low on time, so let's go ahead and do this one quick. The circumference of this is going to be pi times 10, or 31.4 inches. The area of this is going to be pi times 5 squared. Where did the 5 come from? Half of the 10. 5 is the radius. Or 78.5 inches squared. Arc length then is going to be the 31.4 times 40 over 360, which is going to give us 3.6 about inches. Does that look right? Everybody get that? 3.49. We're using the pi key. Yeah, you're right, 3.49. And the sector area then is going to be the 78.5 times 40 over 360, which is giving me, what, 8.72 about? What, 7 what?
726.
So 7.3 inches squared. Okay, I have a packet I'm going to hand out to you. In the packet, it's going to be on pages 165 through 168. There's going to be a few problems that we haven't got to yet.